been. Can you check? I think this rule, we have copied this rule.
Yes, we did.
Okay, so we put our first example. We did an example of that type in our last class of M1. I have a vector 5 Newton and I have a vector of 7 Newton. I want to find the resultant. So can you help me? You can look on the notes and can you help me how I can find the resultant of these two vectors?
We can join them head to tail. The head of the the tail of the 5 Newton can be joined to the head of the 7 Newton.
Very good. And then we will get a triangle and we use trigonometry. Go ahead. Please go ahead and solve it.
The answer is 8.6 Newton.
This is the magnitude. Very good answer. What about the angle?
Angle is 36.5.
No, angle is coming wrong.
Oh, 54.5. If I just I put 5 on top.
Okay.
Sorry.
Now give a new heading, resolution of a vector. We first put the concept. When you're traveling on an inclined path, suppose you are going upstairs, these are the stairs and you're going up. You can notice that when you go upstairs, you travel two displacements. When you go upstairs, you travel two displacements. One is called
Horizontal.
One is called horizontal and one is called vertical. So when you travel on an inclined path, like on a staircase, or the aeroplane, for example, is taking off, or for example, you are going up on a bridge. There are two components of motion. One is called horizontal and vertical. If you break a motion, if you break a motion in horizontal and vertical components, in physics, we call it resolution of a vector. Resolution means finding the two components, finding the two components of the vector. This is how we work out for this. And normally, when we talk about this vector, for example, this is 8, this is 6, then this will be 100 because 6 square plus 8 square will be equal to 100 square. And 10 square. So this will be a concept of vector. This will be a concept of vector that every inclined vector has two components. If you travel 8-meter horizontal and 6-meter vertical, actually you actually travel 10-meter on the slope. Now, this is called resolution of a vector. You have to now copy the definition.
Then
definitions do not appear in M1. So we are not focusing on the definition, but we have to focus on the concept because that will be needed. How we make the resolution of a vector. This is an inclined vector. We will put a double cross, double line on it. And then where the angle is marked, we will write f cos theta and the other side will be f sin theta. In order to find the components of a vector, we will put f cos theta and we will put f sin theta. Now you have to, sorry, you have to copy this screen.
what is F, sir? What does it
F is the
stand for?
force. F is the force, O-level physics. F stands for
Oh yes.
force.
Done.
Whenever you resolve a vector, you put a double line, double cut. This double cut means that you have resolved the vector. The double line means that you have resolved the vector. This is a double cut. So copy this double cut, update it, write resolved.
Done.
Then we move forward for our example. We have taken 20 Newton as a vector. We have taken 20 Newton as a vector and look at the two components. You can further solve them using calculator, but the main idea is to show the components. Now copy this example.
Done.
Now copy this example and try to solve it.
So for F sine theta, it's 5, and for tan cos theta, it's 10 cos 30, it is 5 root 3.
Very good.
I don't know what.
Look at case number 2. Look at case number 2 and especially see the angle. I have marked the angle now with my y-axis. This is a very important concept that cos theta comes where the angle is marked. So look at the angle is marked here. So I'm writing cos here. There's no angle marked here. I'm writing sine theta. This is to prevent a very common confusion that sometimes people think that cos component is horizontal and sine component is vertical. This is wrong. You have to remember that cos and sine are angle marked dependent positions. You have to now copy this screen.
Then
Resultant vector by resolution method. If you want to find the resultant vector, we have three methods: head to tail, parallelogram, and this third one is resultant vector by resolution. Resolution method is the main method which needs maximum practice in M1. It actually comes everywhere in M1. So resolution means decomposing a vector in two components. So now you have to give this heading.
then
What is a resultant vector? When two or more vectors are acting on an object, their final output is called resultant vector. We have copied this definition before also. So suppose that there is 3 Newton and there is 2 Newton. So you will say that the resultant vector is actually equal to 5 Newton. Now I'm showing the steps first. So we'll discuss this method. This is a bit longer method, so we need steps to remember. Step 1, resolve all inclined vector into their components. Step 2, separately find the algebraic sum of x and y component. Step 3, use this formula for magnitude. You have to copy this screen.
Done, sir.
These are the 3 steps. Now, R is equal to resultant vector. For every vector, there is a magnitude and there is a there is a direction. When you want to find the direction, you have to use trigonometric identity tan theta. Now, there is a very important step which we discussed when we were solving trigonometry also, that do not put, if there is a negative sign, if there is a negative value in your calculation, do not put it in your calculator, because calculators actually change the angle position themselves. So we have to copy this screen now.
Done, sir.
Tan theta calculation. Tan theta calculations should always be done on a degree mode, because in M1, remember that radian mode is not needed. This degree and radian issue is a big issue when you are using calculator in your exam paper, and a slight error can make a big problem. So remember that in M1, calculator should be in degree mode. Now I'm trying to get that another concept which is coming from O-level maths and physics also. Now we had a concept that in our axis system, x values and y values change their sign. Look at the screen. If I ask you where 2, 3 will go, you can look on the screen. 2, 3 will go in the first quadrant. Why it will go in the first quadrant? Because they both are plus. 2, minus 3 will go in the fourth quadrant. Why they will go in the fourth quadrant? Because y is negative and x is positive. Minus 1, minus 5, it will go in the third quadrant. Why? Because both x and y are negative. And minus 3, 1, it will go to the second quadrant. So according to the x and y plus minus, we can decide in which position they will go. In the first quadrant, x and y both are plus. In the second quadrant, x is negative. In the third quadrant, x and y both are negative. In the fourth quadrant, x is plus, but y is negative. Now you have to copy this screen. You have to copy this screen, and I'm just coming, copy this, please.
Done.
In the first quadrant, the angle is acute and we call it basic angle. In the second quadrant, it will be 180 minus theta. In the third quadrant, it will be 180 plus theta. In the fourth quadrant, it will be 360 minus theta. For example, let's say the basic angle is 30. If you go in the second quadrant, it will be 150. And if you go in the third, I hope you are remembering it. We did this in our chapter of trigonometry. Are you able to recall it?
Yes, sir.
Good. This was something we did in our chapter of trigonometry. Now, only inclined vectors are resolved. Horizontal and vertical vectors need not to be resolved. If a vector is horizontal, if a vector is vertical, you do not need to resolve it. You have to copy this screen now. Do you remember ASTC?
Yes, cast diagram.
Yes. You have to see the horizontal and vertical. There are two vectors and we resolve only the inclined vector.
Yes. I'm done with this, sir.
Now, copy the first example.
Yes, sir. Done.
Now, see the first step. Step number one, resolve the inclined vector. Only one vector is inclined, 10 Newton. So you resolve the two vectors, copy this one.
Then
Now, what is the next step? See the step number.
this is our step number 1.
This
Step
was
number and 4, step number 1.
this is step number 1.
Yes.
So look at the notes. What is the step number 2?
It is to separately find the algebra sum of x and y components.
And what's the formula written in front of it?
It is r is equals to square root x squared plus y squared.
No, the box formula.
Oh, x is equals to r right minus left and y is equals to up minus down.
Now apply this here.
Okay.
Look at the working. Right minus left and up minus down.
The answer I'm getting, sir, is minus 6 plus 5 under square root 2.
For x.
For x I'm getting 7 minus 5 square
Sorry.
root 2.
No.
7
But convert it into decimal. No?
minus 0.07.
Are you sure you're getting this answer? Calculator is in degree mode.
Yes, it is in degree mode.
So please write it again. 10 cos 45 minus 7.
10 cos 45 minus 7 gives me 0.07.
Now it's looking fine. Please do the calculation carefully and do it at the second calculation also.
Okay. Second calculation is 1.07.
Very good. Now look at carefully that what is the first step. If we go back and look at the first step, what is the first step?
First step is to resolve the inclined vectors, and then second step is to change them into their algebraic sum by right minus left, and that will be x, and for y it will be up minus down.
Good. And we got the 2. Now can you look at the third step in the notes?
Third step is this formula R equals square root x squared plus y squared. That is for resultant vector.
Yes. Do this calculation.
Sir, I'm getting the answer 1.072 for the resultant vector, and for the direction or theta, I'm getting 86.2.
Good. And look, the x and y both are plus.
Yes.
The calculation.
So they fall into the first quadrant?
Yes. Now update and write under the first quadrant.
Sorry?
Write this x plus y plus first quadrant in your solution.
Done.
Now remember that angle theta in the first quadrant, no further step is needed. Otherwise, you have to change the quadrant. You have to now copy this.
Done.
Now, it means that you need to see the sign plus minus of x and y. Now you have to copy the second example.
No, I would like to know what further answer, like how would we just the final answer if it's not in the first quadrant?
So just like, for example, the x and y are, look at this working. If x and y are some other number, like, so if your answer is 30, you want to come in the second quadrant, it will be 150. And if you want to come in the third quadrant, it will be 210. If you want to come in the fourth quadrant, it will be 330. Do you remember how we used to find angles in trigonometry? We discussed that topic in advance.
Yes.
That is how the same way ASTC, you will do the same logic here. And that is the point of trigonometry here. I just wrote it for formality, but actually we did it in trigonometry that you can switch to other angles, other quadrants using the idea where the angle is lying. You want to go to second quadrant, you want to go to third, or you want to go to fourth quadrant. Now, example number 2.
Yeah, copy this example.
Okay, now which vectors should we resolve?
I think we should resolve all of them.
Yes, very good. So the first step is there, resolve it.
Done, sir. It's the same as yours. The labeling.
This is the formula, right minus left, up minus down. So I have marked the right and left, up and down. So mark in the same way.
Done, sir.
Now, do the calculation step for x and y. Do the calculation step for x and y.
Sir, the answer for y is 54.6, whereas the answer for x is 53.8.
Answer for X is 13.3.
Okay, let me check where I got it wrong.
Again.
I haven't done anything wrong, but I'm still getting 53.8.
53.8 is fine.
It's the answer to right. We can consider it.
53.8 is 54. That will fine. What about X? What X you are getting?
I'm getting x as 53.8.
Hey?
Y, yes.
No, but
Y
can you
is
look on the
54.6.
screen? Please compare the variables up.
Yes, I did. It's the same. 30 sine 30 plus 50 cos 30, and then minus 7 cos 50.
Minus 70.
Oh,
It was not 7. You have to be very careful. 7 was not there.
it's 13.3. They both are positive, so we wouldn't have to need a further step, right?
Yes. So please
Mm,
correct it.
yes, I did correct it. Sir, I'm done with this.
Then you have to proceed to the next step now. The magnitude step. Let me know once you get the value for R.
The value for R is 56.2.
And the angle.
I'm finding still.
आज किधर जाना था
13.6.
15.6, but I'm getting 76.3.
Okay, wait, let me check. Yes, 76.3. I'm getting to.
Did you check the values that these are the X and Y values? X is 13.3 and Y is 54.6.
Yes. Right, sir, can we finish it here today?
But we have to complete this part now. Can you please confirm the angles?
Yeah, it's 76.3, the angle, and the resultant is 56.2.
Okay. So then we are done with today and we will inshallah continue in our next class.
All right, inshallah. Allah Hafiz.
Allah Hafiz.